Today we're here with Dr. Carlos Azambuja. He is the director of Genia. Thanks for being with us today, Carlos.
Thank you for your invitation. I'm glad to be here.
Can you tell us a little bit about your work at Genia?
Well, Genia is a service company that is devoted to using DNA and molecular methods in general to assist the seed industry in order to improve their quality and their productivity.
And I understand that you use AgriSeq targeted GBS. Can you tell us a little bit about how that was used in your most recent research project?
Well, you know, we have been contacted by the barley industry because there was a challenge to develop a method that would be able to detect very few contaminants, varietal contaminants into the main varieties. And for that, the first approach we had was to use it analyzing individual seeds, but we weren't able to analyze more than 100 seeds, and that would introduce a big sampling error. Theoretically, to diminish this error, we needed to analyze as much as 10,000 seeds, and that would be impossible to do in an individual basis. So that's what we decided to try to do it through the AgriSeq technology, in which we would be able to analyze those 10,000 seeds by grinding them together and extracting the DNA from the powder of this pool of seeds. And that statistically would be equivalent to doing 100 independent reactions.
And what were the results of your key findings from your study?
Well, the key finding was that with as few as 400 markers, which is a panel relatively small, we were able to achieve levels of sensitivity that would detect less than up to 0.8% of contamination with a confidence interval of 99%. So that is something that was not achieved before with other techniques.
I mean, that's just not been done before, right?
No, this approach, as far as I know, is new, and perhaps a very critical issue is that the next generation sequencing technology itself was a little bit too expensive for these applications. But what AgriSeq did, what Thermo did, was to downsize, to diminish very much the price of the AgriSeq libraries, and that turned them affordable for these applications.
How does AgriSeq targeted GBS compare to other technologies that are available today?
Well, there are several factors that would make AgriSeq GBS an election, because in one side you can address several markers at the same time, but at the same time it's have a very high throughput. So this, together with the lower price, with the lower costs, represent a tool that can be readily adopted for variety purity determination.
And what kind of overall impact do you expect for this to have with seed producers?
I think that this is a very useful tool because it permits to very high levels of quality controls. For example, in the multiplication process, which is very important in the seed production, you can use this method to test if the seeds that you get back from the multiplicators is exactly what you want it to be multiplied, or if it is contaminated or not. So this would improve very much the quality of the seeds.
What would this mean for a typical seed company?
This would mean that they would be able to monitorize much more precisely the whole process of the seed production, because variety contamination is always a challenge And with this tool, you can detect very tiny amounts of this contamination, so it would improve very much the quality of the products.
And how do you see this work evolving over time based on the project that you've just been through?
I think that this tool developed with this approach will become a gold standard in the industry, because I am convinced that it is a very good solution for the problem of detecting tiny amounts of varietal contaminants.
And you've used it in barley and any other crops?
Well, up to now, we are using it mainly on autogamous, on barley and on soybean. We developed a panel for those two species, but now we are trying to use a similar approach for eucalyptus and for clover, and to see if we can have similar results in allogams.
So that's the kind of the next step is to test it and see if you get consistency across multiple crops.
Yes, that's our next step, and we think that there is a very good opportunity in the allogamous seeds, because it has always been a challenge to define the variety, because different from the autogamous, and autogamous you have a lot of homozygous individuals, so it's much more easy to define them. But in allogamous species, you need to define the frequency of different markers in the population, and that can be achieved mainly with this technology and not with any other.
What kind of advice do you have for new labs that are really kind of starting out exploring this kind of targeted GBS technology for seed lots in QC applications?
Well, I think that what we have seen is that it's a very robust technology, so I wouldn't doubt in go into it, because the results we got demonstrate that it's very reliable and very reproducible. So I would very much advise them to adopt this technology.
Can you comment a little bit on your overall experience working with Thermo Fisher Scientific?
Well, the overall experience was very nice, was very good. We had a very good support from the scientific development area. We got a big help from them for developing the panels of markers, which is a key issue in this technology. And we also had a very good support from the bioinformatics area, which was also a big challenge.
Great. Well, thanks so much for all the information today, Carlos.
Thank you for this interview and to give us the opportunity to show what we are doing.
Great. Thanks so much.
Thank you.